Guys, check this out. I was trying to write a textbook for my students, and I designed this awesome resource. I'm calling it the Periodic Table of Elements.
I don't know what he's talking about.
That's awesome. Well, I hold 355 patents, including one for this nifty stuff called dynamite. This is just going to blow up the mining industry.
What?
Well, for long-term implications, I think I'm really onto something. I've found that some of the elements Mendeleev here has labeled sometimes deteriorate into different ones entirely. I'm calling it radioactivity.
Wow, if this was a contest, I'd give you a prize for that.
I mean, I guess it's cool.
Whoa, hold on there, guys. I'm going to knock your socks off.
You gotta be joking.
Dang, did you discover dynamite too?
What if I told you I could identify the structure of an organic compound in just one step?
If you're talking about that new Bunsen burner of yours, I've seen it. Let's not get too excited.
Blinded by the light, sitting in the lab, NMR on my mind. Blinded by the light, flip and spin states, there's no doubt that I'm right. Blinded by the light, let's break it down, I promise it won't take all night.
What do you mean, flipping between spin states?
Well, in the presence of an external magnetic field, a signal of proper frequency may cause a change in the spin states to a higher energy state.
Electromagnetic field against spinning nuclei. Energy states have a fate, alpha to beta raising high.
Wait, what is the difference between alpha and beta states?
Alpha and beta are different spin states. Atoms in the alpha spin state are aligned with the external magnetic field, and atoms with a beta spin state are aligned against the external magnetic field.
Torsion of a photon will make it move on to a higher energy state. Electrons shielding, not letting protons yielding. Times affect the chemical shift. Times affect the chemical shift.
What is chemical shift?
The chemical shift is the resonant frequency of a nucleus relative to a standard in a magnetic field. The chemical shift is plotted on the x-axis of an NMR spectrum, and it helps you identify a compound because hydrogen atoms have different chemical shifts based on their environment.
Blinded by the light, chemical shift shows electron shielding might. Blinded by the light, chemical shift shows electron shielding might. Tetramethylsilane, abbreviated TMS, is what our diagram shows best. Magnitude of delta E on our spectroscopy is what we would like to address. Parts per million differentiate the photon from blending with all the rest. NMR in whole show the electron role in forming unique compounds.
Wow, this puts the entire field of chemistry in a whole new light.
I'd give you a prize for that too.
What? You gotta be joking.
You will, actually. Many of them.
I don't know what he's talking about.
Who knows in the next century what new advancements this will bring?